Good morning, stats. We are moving along to 3.2, and this is, as you can see, sampling good and bad. So as we move forward in deciding what type of samples that we have, there are obviously good choices and bad choices, and we're going to talk about those here in this section. So if we take a look at the first objective, it's to describe how convenient sampling can lead to bias. Okay. There is an activity up I'm going to put up on Edge Elastic. You're more than welcome to do it. It's a great intro to this section, and that will be up. You don't have to do it. It's not for a grade or anything, but it's a good kind of intro to sampling as we move forward. But convenience sample. So choosing individuals from the population who are very easy to reach. And we have to have some caution here as this can produce unrepresentative data. If we do what's easiest, a lot of time we don't get the best data, and therefore it's not very good sampling. So anytime that we have a convenient sample, a lot of times that is bad sampling. Okay. And then we have what we're going to talk about a lot this chapter is bias. The design of a statistical study is bias if it would consistently underestimate or consistently overestimate the value you want to know when the study is repeated many times. Okay. Bias is not just bad luck in one sample. It's continuously done over numerous amounts of time. So we have to make sure that we don't have bias. It's not just bad luck. It's a result of a bad study design that continuously or consistently misses the truth about the population. Okay, so let's take a look at an example here. Orange, you thirsty? A farmer brings a juice company many crates of oranges each week. A company inspector looks at 10 oranges from the top of each crate before deciding whether to buy all of the oranges. Explain why this sampling method is biased. Okay, so why is this method here biased? And hopefully that you understand that it's biased because he's only taking oranges off the top of the crate. The more oranges in a crate, the more poundage and weight on those bottom oranges. So it's likely that those oranges on the bottom are not in as good a condition as those from the top. So in explaining this and writing this down, we're going to kind of use this wordage here. It is likely that the oranges on top of the crate are in better condition than the rest of the crate. Okay, so this would be a biased method, again, because we're only looking at the top. Then it asks you to explain why this sampling method is biased. Is the proportion of damaged oranges in this sampling likely greater than or less than the proportion of all oranges in the crate that are damaged? And again, clearly, it's the proportion is probably less than the sample that would be taken from the bottom. So if you're taken from the top, it's probably less than. So again, the oranges on the bottom may be damaged due to the weight of the oranges. Okay, and again, why is this bias? What type of bias? What could we do to, the farmer may put the best oranges on top, knowing that they're going to take this. So the sample proportion of damaged oranges is likely to be less than the proportion of all oranges that are damaged. And again, that should make sense. And this is, again, the convenience of just choosing the 10 oranges on the top as opposed to digging through and getting on the bottom. So there is one example of a biased survey and a convenience sample where that sample is on top. Again, you might want to mention that this is the convenience of choosing oranges on top. Okay, and again, bias because the farmer might put those on the top. We know that they're going to be less likely damaged on the top. Let's take a look at objective 2. Describe how voluntary response sampling can lead to bias. So a voluntary response sample consists of people who choose to be in the sample by responding to a general invitation. Okay, a lot of times this if you choose to volunteer, it's because you feel strongly about an issue. Okay, particularly negative feelings. If you have a negative feeling towards something, a lot of times if you go to and you want to buy like a new appliance or something, you go through and read the reviews. A lot of times there's either very good or very poor reviews for those things. So you got to keep that in mind when you're looking at the sampling for a voluntary response sample. You don't have to do it. You put it out there for everybody, and only those who want to respond do respond. Okay, so let's take a look at this example. Is that bias pushing up the mean? The athletic department at El Dorado Community College wants to learn more about the physical fitness of students at the school, including the number of push-ups that students can perform. To obtain their sample, the athletic department sets up a booth in the center of campus with a sign that says free physical fitness testing. Explain why this sampling method is biased. Is the mean number of push-ups for the members of their sample likely to be greater than or less than the mean number of push-ups for the entire student body? And when I read this problem and I think about it, probably if you're not very fit, you're not going to get down there and do 1 or 2 push-ups, or even 0 push-ups, get down on your knees and do push-ups. Probably only the students that are most fit are going to stop to actually do this push-up. So we would say it is likely that only physically fit students will volunteer for the testing. It is likely that only physically fit students will volunteer for the testing. Okay, so students who aren't in good shape are unlikely to volunteer. Again, that's kind of implied by saying it's likely that only physical students will fit. So as a result, the mean number of push-ups, okay, as a result, the mean, again, what does the mean mean? The average number of push-ups is likely to be greater. Spell that, greater than the mean number of push-ups for the entire student body. Again, not a ton of numbers here, but again, we're kind of describing this data and hoping that this makes sense. So again, is the mean number of push-ups for the members of their sample likely greater than or less than? That's what we would be answering here. And it's likely greater than because only the physically fit people would be willing to stop and actually do the push-ups in this. Okay, so again, we have to watch that bias and of our sample. Okay. Explained how random sampling can help to avoid bias. So random sampling involves using a chance process to determine which numbers of a population are included in the sample. Okay, so again, it's a chance process. It's not given directly to a person. It's just by chance that this person is selected. So can we get some unbiased push-ups? Explain how the athletic department at El Dorado Community College can avoid the bias identified in the previous example. So what could we do in this? Instead of recruiting volunteers in the middle of campus, the athletic department could obtain a list of students and randomly select. So they could have everybody in the college do push-ups and then randomly select 100 or a certain sample of those to record the number of push-ups. Okay, so instead of recruiting volunteers, in the center of campus, the athletic department could obtain, so we could, I'm just going to shorten this, obtain a list of all students and randomly select a sample. Could choose 100, could choose 200, could choose 1,000, okay, for the physical fitness test. Okay, so no personal choices involved. This sample should be more representative of the student body. So no personal choice was involved. So should represent should be representative. Sorry, should be more representative of the entire student body. Again, that should make sense, but again, there's no numbers here. Again, we're looking at this, and if we look at the first objective, we're looking at, convenient sample. So is it likely or less likely? More likely, less likely. This is what I'm looking for. It is more likely that the oranges on top of the crate are in better condition. Same thing with the second one. When we're looking at these, we're using the word likely. It is more likely that only physical fitness. So more likely, less likely is what we're looking at. So you have a 3.2 Edulastic assignment for this.